Yes guys, so we are doing question number 3. Okay, in the question number 3, what we have? Third question. Find the common area between the curves y square equal to 4ax, and as I told you that these two curves are parabolas. Okay. Now let me describe these parabolas. The first parabola, this one, is even powered in y. Okay, so this is further discussion in case of Cartesian coordinates or Cartesian equations. Okay, so finding the area under the curves, or this is known as quadrature, which we are discussing here. Okay, further I've taken these 17 questions on the demand of student side. Okay, so they have asked me these 17 questions further. So because of that, I'm describing them in these questions so that they can understand every step of this clearly. Okay, how to find out the common area between two curves, which I have already described in the definition part. Let me take this question. Okay, so y square equal to 4ax. Now this is first point. Let me describe the first parabola. Now first parabola, this is, let me take first equation, and this is the second equation. So first I'm talking about first parabola. This first curve, let me take first curve of parabola. First curve is symmetric. Is symmetric about x-axis here. About x-axis. Why? Because y is even powered, which we have discussed in tracing of the curves a number of times. Okay, so it's about x-axis as y is even powered. As y is even powered. Okay, so second point. Second curve is symmetric about y-axis. Okay, it is symmetric about y-axis. Why? Because it is even powered in x, as it has x as even powered. X as even powered. Now third point, both are passing through the origin, but there are no constant term in each. Both are passing through the origin. This only a brief I'll discuss about the origin as no constant independent term. As no constant independent term. No constant independent term is there. Okay, this is what we call. Okay, what do you call? Yeah, parabola. So they are passing through the origin. Now let me draw that what is then the curve required. So here the first parabola is this. This is the x-axis here, origin O. Second parabola is symmetric to y-axis. Now this is the common point here. Let me take. Now this is the common area which we have to describe. So this is, let me take OA, and let N is the normal perpendicular. Okay, from A to B. So on x-axis. What is the common point here we have to discuss about? So this is the difference between the area under the first curve minus area under the second curve, because this arc is of the second curve. This is x square equal to 4a by this first one. Sorry, the second one. This first one is y square equal to 4ax. So these are the two curves here, parabolas, which we have described. So this is the common area which we have to find out. For that we require this common points. So what are the common points here? 0, 0 is one of the points. So this is 0, 0. And second point is this common point. So what is the intersecting point? Let me find out that. So finding the intersecting point. So common intersecting point A is given by is given by how we have to talk about. So putting, if I square this and putting that value here, then we can find out. So by square we have to find out. Okay. So from squaring second, okay, squaring second, we get that will be x4 is equal to 16a square by square. Now in place of by square, if I substitute this value, by square equal to 4ax from first, so this is third one, let me take. Substituting value of y square from first into third, so okay, into the third one. So what we get, x4 is equal to 16a square into y square is 4ax, so into 4ax, that means aq into 64, so this is x4 minus 64 aq into x equal to 0. If I take x common, it will be x cube minus 64 aq equal to 0. This implies that x equal to 0 and x equal to 4a. Why 4a? Because 64 cube root is 4. 4a whole cube this is, so x equal to second point, x cube minus 64 a cube is equal to 0, or x cube is equal to 64 a cube, or x equal to 4a, because 4a whole cube is 64 a cube. So these are the 2 points here. Okay, so at y is equal to 0, what we have obtained? 0, 0, first point, y is 0, x is 0, and y is 0, and x is 4a. Okay, so second point, sorry, we have to find out, because here if I put x equal to 0 in the first one, y is 0, this first point. If I put x equal to 4a in the first one, x equal to 4a here, so y square from first. At x equal to 4a, what is y here? Y square equal to 4a into 4a, because in place of x we have substituted 4a in first equation. At x equal to 4a, this is from first. Therefore, y is also equal to plus minus 4a. So y is equal to plus minus 4a. That means this point is also 4a. This is 4a and y coordinate is also, 4a. So y is 4a, x is 4a. Okay, so if I take here, let me take a strip, elementary strip here. This is PQ point. Okay, M and N point if I take. And this is dx, the breadth of this strip. Okay, so the area, common area can be given as, let me now put the common area. Therefore, common area will be given as, this is A point here, the common area of the two parabolas is equal to, this is only single time because this is the common area only, no other common area are there. So this is the first parabola. So for the first parabola, y dx is equal to how much? Let me write here. So the first parabola is limits, let me put 0 to 4a because x limits are 0 to 4a here. This is x equal to 4a at this point. N point, so up to 0 to 4a is also 4a, so 0 to 4a. Okay, and y dx minus 0 to 4a, and this y, let me take f1x. First one is f1x, second is f2x into dx. For the first parabola, value of y dx or y is equal to, here y is equal to 2 under root ax, because it's square root. Y square is equal to 4ax, therefore y is equal to square root of 4ax, that means 2 under root ax. This is value of y. And for second, so here it is 0 to 4a, 2 under root ax into dx. For the second one, and for second one, let me take the second one. For second curve of parabola, y dx, or this is 0 to 4a, is equal to, here y is x square upon 4a, this is x square upon 4a into dx, 0 to 4a. So from second parabola, we have to find out value of y. Y is equal to x square upon 4a. Substitute the value of this. So in this place, we will substitute minus 0 to 4a into x square upon 4a into dx. So these are the two values of y dx by dx. Okay. Now let us solve it. So finally, that common area can be calculated easily now. So what's the common area? This is equal to, first 2 under root a, that means a raised power half. We have taken outside constant value. So under root x 0 to 4a, this is x raised power half dx left over. This is under root x, under root ax, that means under root a into under root x. The square root x is x raised power half, minus sign. Okay, and here it is 1.4a. Let me take outside 1.4a. 1.4a constant value into x square 0 to 4a, same limit, into ds. Okay, so this is to be integrated now. Let me integrate them and finally find out the value. 2a raised 4a, 2a raised power 1.2 outside. Integration of x square is x 3 by x half power is integration x raised power 3 by 2, because 1 is added here, 1 plus 2 plus 1 divided by 3 by 2, that means 2 upon 3 into 2 upon 3. Minus sign, this is 1.4a, integration of x square is x cube upon 3, 0 to 4a limit, here also 0 to 4a limit. Now let me substitute the limits here. So what are the limits and finally solution? Okay, so this is 4a whole power 3 by 2. And 2 upon 3, let me take outside, this is 4 upon 3, a raised power half. And in the bracket x raised power 4a, that means 4a whole power 3 by 2. I'll solve it. 1.4a, this is and into 1.3 outside. X cube is 4a whole cube. Okay, so this is equal to, now this 4 can be written as 2 raised power 2. 4 is 2 into 2, that means 2 raised power 2. 2 raised power 2 to cancelled out. It is 2 raised power 3, that means 8 here. So it is 8, 4 upon 3, a raised power half into a raised power 3 by 2 into 4 means 2 raised power 2 whole power 3 by 2. Now it's okay. Minus 1.12 into a into 64 a cube. 1 a cancelled out, this is twice. 4 3s are 12 and 4 16 times. Okay, so 16 4s are 64. And now what about this one? This is 8. For this 2 to cancel out, 2 raised power 3 is 8. 2 into 2 into 2 3 times, that means 8. And this a raised power half plus a raised power 3 by 2 is a raised power 4 by 2, that means 2 a square. So 8 4 is 32. 32 upon 3 into a square minus, this is 16 upon 3 a square. Okay, so they are similar type value. The remainder is 3 LCM if I take, and a square is common, so this is 32 minus 16 is 16 upon 3 a square. This is the answer here. Can be written as a square unit area, because it is area here, answer, or unit sometimes is not written here. So it is only 16 upon 3 a square is the answer of this question. Question number 3 we have solved. Question 3 is having common area of the two parabolas as 16 upon 3 a square. Okay, so this is question number 3. Now let us talk about next question. Question number 4. So what does question number 4 say? Let me check it and then solve it. Okay, now question number 4. Let's talk about it. Question 4 says find the area enclosed between the parabola y square equal to 4ax and x square equal to 4b by. Okay. Now here is a bit difference. Here it is 4b by. In third one it was 4a by. Okay. So parabolas are similar type, but a and b are different values. No problem. Let us talk about fourth question. So area between, we have to find out area between parabolas of curves. First parabola is again y square equal to 4ax. This is first equation. And second is x square equal to 4by. This is second one. 4b by, second question. Okay, second parabola. Again, the common area. So let me describe the same common area. The first one is symmetrical about x-axis. This is symmetrical about y-axis. So first parabola is this x-axis origin, and second parabola is symmetric about. Okay. Here the main thing is only the common area. Curve can be drawn in any way, but common area should be shown here. This is suppose A again. Let me draw a perpendicular. This means x-axis, that end point let me take. Okay, so what are the coordinates of A that we have to find out, and then 0, 2. This is 0, 0 origin, because these two parabolas are also passing to the origin. This is symmetric about x-axis, this is symmetric about y-axis, symmetric about y-axis, this is y-axis here, y dash, this is x dash. So x-axis, first parabola is symmetric about x-axis, that means similar shape can be found above x-axis and below x-axis. This is symmetric about x-axis, this is symmetric about y-axis, because y on the two sides of y we have the similar shape of the curve. Okay, that is this point here. Now let me talk about the common area here. So first we have to find out what are the common points here. If I find out the common points, again squaring second equation, the common area, this is solution we are finding out. Okay, so we can just talk about the first parabola. The first curve, let me take. The first curve is symmetric about x-axis. Okay, region you can write that y, because y is even power. Second is first curve. Second curve is symmetric about y-axis. Okay, third point. With the third point here, both are passing to the origin. I have already described in the question number 3. Similar type of question is both are passing to the origin. A bit regarding the tracing can also be written down to the origin. Why? Because there is no constant independent term in both. Here variable, multiple of variable, here multiple of variable y. No independent constant term is there. If there is any independent constant term, then that curve will not pass to the origin. But here both have no independent constant terms, both are passing to the origin. Okay, now common intersecting points. For intersecting point, for intersecting point, which is A here I have taken. What we do? We solve both the equations. So let me square both second equation. So squaring second equation we get x4 is equal to 16b square y square. Now this is third equation, let me take. Now substituting value of y square from first equation in this third one. So substituting value of y square from first in third. What do we get? So we get here x4 is equal to 16b square. Y square is here 4ax into 4ax. Okay, so this is nothing but x4 equal to 64 b square into a into x. Taking this implies that x, if I take common, then it will be x cubed minus 64 ab square. Try to understand. Therefore, and this is equal to 0, therefore x equal to 0 and x equal to, from this one, 4, because 4 cube is 64, square root of 64 is 4, into a raised power 1 upon 3 into b raised power 2 by 3 cube root of a. Cube root of a is 1.3 and cube root of b square is 2 by 3 power. So this is the value of x here. Now if I substitute this value of x in the first equation or the second one, doesn't matter. Value of y can also be calculated. So for value of y, let me substitute this value of x in this first one. Okay, so first 0 point, because at x equal to 0 anywhere, x equal to 0 in first one, y equal to 0. So this is 0 point, first point. For second point, okay, if I substitute value of x in the first one, so what we get? So y square is equal to 4 into a into x. X is 4 into a raised power 1.3 into b raised power 2 by 3. This substituting value of x, okay, x in first. This we have obtained. So y square is equal to 16 a raised power, because 1 plus 1.3 is 4 by 3. Is 4 by 3 into b raised power 2 by 3 only. Okay, therefore y square plus minus, it may be 4 into a raised power 2 by 3. Why 2 by 3? Because multiply by 1.2 and 2 to the 4. So 2 upon 3 and b raised power 1.3 only. Because if I multiply this 1.2, 2 to cancel out, because the square root of b raised power 2 by 3 is b raised power 2 by 3 whole 1.2, 2 to cancel out, so 1.3 power left over. So y is plus value, because this point only you have to calculate. So let me write here. Value of x coordinate was 4 into a raised power 1 upon 3 b raised power 2 by 3 common, and this is 4 into a raised power 2 by 3 b raised power 1.3. These are the two coordinates, x coordinate, y coordinate of point A. Okay, now let me find out what is the common area then. The common area for first by dx can be calculated from here, which is under root 4 of ax, y equal to under root of 4ax. Okay, so for first curve, because here we are taking this first curve above. So first curve is this one, which is this y square equal to 4ax is the first curve. Second curve, this is x square equal to 4by. This is the second curve. Okay, for first curve, by dx, integration by dx, and 0 to x coordinate is 4, a raised power 1.3, b raised power 2 by 3, because x coordinate only, by dx minus same limits 4, a 1.3, b raised power 2 by 3, and this, if I take this as by dx, otherwise they have to be expressed in different ways. So let me take this as f1x and this is f2x into dx. For first curve, by dx is equal to, okay, for first curve, this is common area. For first curve, let me find out. For first curve, y is equal to square root of 4ax. That means 2 under root a into x. For second curve, y is equal to this one, x square upon 4b. Simple. X square upon 4b, y is equal to. So we have to substitute these values here. So the below parabola is second and first above. So from above, we find out the area, limits from 0 to this 4a x coordinate. Then this whole area will be calculated. What area? OAN, total area. And then if I take this as B, this point, at this point, then we have to subtract the area of the second curve, which is OBAN. So this area white portion, unshaded portion, is to be subtracted from the first one. That will give us common area, which are represented here. So this is 0 to 4a raised power 1.3, b raised power 2 by 3, f1x first is 2 under root a into x under root means 1 upon 2 power into dx minus sign 0 to again 4a raised power 1.3, b raised power 2 by 3, okay, b raised power 2 by 3 into, this is second y, x square upon 4b into dx. We have to solve these two equations and then substitute the limit. Let me solve it here. So what is the final common area? So common area is equal to the first one integration. So 2 a raised power half I have taken outside, and then x raised power half is to be integrated. 0 to, let me write the limit, a raised power 1.3, b raised power 2 by 3 into, this is x raised power half into dx minus sign, okay, this is 1.4b outside, 0 to, again this is 4 a raised power 1.3, b raised power 2 by 3, b raised power 2 by 3 into x square into dx. Now let me integrate them. So finally the value can be found out. So first integration, x raised power half is x 3 by 2 upon 3 by 2. Then 2 raised power half, x raised power 3 by 2 divided by 3 by 2, let me write, limits 0 to 4a power 1.3, b raised power 2 by 3. Okay, this is the first one. Second, 1.4b x cube upon 3 integration, limits 0 to again 4a raised power 1.3, b raised power 2 by 3. Okay, the first one, 2 by 3 will come out, that means 4 by 3 here, 2 to the 4, 4 by 3 into a raised power half, putting value of x raised power 3 by 2. Again, 4 raised power 3 by 2 is 8, okay, and a raised power, so let me put them, a raised power 1.3, b raised power 2 by 3 whole power 3 by 2. Okay, into, now 4 raised power 3 by 2. That means 2 raised power 2 whole power 3 by 2. Constant term which are a raised power 1.3, b raised power 2 by 3 are taken outside and putting the value power 3 by 2. This we will solve separately. 1.4b into 1.3 taken outside. X raised power this value. Again this is q here. So this is 2 raised power 2 whole power 3 by 2. Sorry, only 3. This is 3 only, or 4 raised power 3, doesn't matter. This is 4, let me write 4 raised power 3 only. Why? Because this is x cube. X cube means this whole power 3. Okay, and this is a raised power 1.3 into b raised power 2 by 3 whole cube. It will give us. Okay, so let me solve it further. Now a raised power 3 by, that means 1.2 plus 1.2, so a only will be there. It is 4 upon 3 into a. Why? But a raised power half. This is 1.3 a raised power whole power 3 by 2. So 3 cancel out, 1.2 power left over. So a half plus a half is a raised power 1. That means only a. Then b raised power 3 cancel out, 2 cancel out, only b. So this is nothing but 4 by 3 AB. Okay, and 2 by 3 that I have already taken outside. I'm sorry, this 4, this 2 raised power 2 to cancel out. So this 2 raised power 8 is also there into 8. This value is 8 we have taken outside. So 8 for the 32 upon this minus sign 1 upon 12 b. 4 3 are 12. 4 is power 3 is 64 into 64. Again whole cube. So this is a into b square. 1b cancel out. Okay, again this is 4 3 and 4 16 times. So what do we left with? We are left with, therefore common area is equal to the common area. Calculating here, common area is equal to, the first is 4 8 is 32 upon 3 AB minus sign, this is 16 upon 3. This is also a into b because 1b cancelled out, so this is also AB. So simply this 32 minus 16 is 16.